trig functions of any angle. Okay, here's the dreaded unit circle. The radius of a unit circle is constant 1, and the angle theta points to a word pair on the circumference. So what we've done now is we've superimposed actually our trigonometric circle, our triangles, collection of triangles, if you will, as we rotate around the axes. And so now we can refer to the side lengths as x and y instead of a, b, or c if we want to. On the previous slide, you'll notice that for any angle theta, there exists a corresponding ordered pair of Cartesian coordinates. And each pair satisfies the equation for a circle, x squared plus y squared plus r squared. If the radius is 1, the equation becomes x squared plus y squared equals 1. So you could draw all of your triangles. This doesn't matter. It's all a question of proportionality. With the hypotenuse equal to 1. And obtain trigonometric functions on the unit circle. Take a look at angle theta less than pi over 2. We've already done that. Notice the vertical angle. It forms a right triangle with the length of the hypotenuse equal to 1. X as the length of its adjacent side, and y is the length of its opposite side. So sine theta becomes opposite divided by hypotenuse. So the sine theta is equal to y, the cosine theta is equal to x, and the tangent theta is equal to y divided by x. But suppose we had an angle bigger than 90 degrees, so pi over 2 radians. We apply the conclusions below to the right triangle formed by x and y. Same thing. Note that the x-coordinate of all peripheral points is negative for theta greater than pi over 2 and less than pi, but y is positive. Therefore, since cosine theta equals x, the cosine of all angles between pi over 2 and pi is negative and has an absolute magnitude less than or equal to 1. The tangent is also negative. You're going to have to do some concentration on this to see this, but I think you can see that if you know how to use the Cartesian coordinate reference frame, that in the second quadrant, x is negative and y is positive. So here we've gone to the third quadrant, and this will require the same amount of scrutiny on your part. And we conclude from our progress so far that the domain of the angle theta is 0 to 2 pi radians, and that the range of both sine and cosine functions are -1 to +1. And that the tangent of theta gets really, really big, around 90 degrees or pi over 2 radians. There are 3 additional trig functions that we've not discussed. We'll just mention these in passing, as for our purposes, the 3 we have discussed are certainly adequate. And they're the ones that are on your calculator as well. So angles larger than 2 pi, by assigning the letter n, we can expand that domain of theta. So in a second revolution, we could write n times 2 pi, so it would be 2 times 4 pi. 2 circles around would be 4 pi radians. 3 times around would be 6 pi. So an angle of 11 radians would equate to 5 complete rotations of 2 pi and a single half rotation of pi. Special angles, referring back to the special triangles we covered in the handout, we can see that we can, just by inspection of these 2 triangles, we can find values of sines and cosines quite easily, and tangents as well. I would suggest you do this for a while to get accustomed to that, and then you can revert to punching the numbers into your calculator. Here's some fundamental identities that apply to sine and cosine functions. I'll let you take a look at these. You can also find a lot more online. And finally, we need to discuss functions of time. You can read through this. If you have questions, you can contact me or post questions on your campus site.